Alright, tonight's lesson is solving quadratic equations by graphing. This says to start with a graphing calculator. I know you don't have one at home, but check it out. I have already put in the 2x squared minus 4x plus 3, and the problem says to find on the table when it's equal to 9. So as you can see right here, 3 gives you 9, and then if you go back, negative 1 gives you 9. So we're going to use that data and graph right here. So I'll go ahead and make the table. So the calculator gave us negative 1, 9, 0 giving us 3, 1 giving us 1, 2 giving us 3, 3 giving us 9. Probably the easiest method. So this is where it's equal to 9. We're going to look at that a little more algebraically now. If you plug 9 in for y, you can solve by subtracting 9 from both sides. So we get that. Next, you can graph that by taking out your greatest common factor. And this is factorable. Two numbers that multiply to give you negative 3, that add to give you negative 2, are negative 3 and positive 1. And that's equal to 0 still. So I really understand now that 3 is going to give me the solution of 9, which is what I initially plugged in. And negative 1 will give me the solution of 9, which is what I initially plugged in. So on my graph here, this is my axis, 3, and at negative 1, I have 9. Alright, the second graph there, the grid is wrong, so we're going to analyze this on the first graph. So at 3, we're up here at 9, and at negative 1, we're up here at 9. And therefore, we know that our symmetry is directly in the middle at 1. And to get the vertex, you could plug 1 in. So 2 times 1 squared minus 4 times 1 plus 3 is 2 minus 4 plus 3, which is 1. So 1 gives you 1, and that's your vertex point. Since you know it's a parabola, you only need 3 points. Those are your 3 main points. So here's our third main point. So if we, again, are going to solve by graphing, the first step is to factor. And this is the difference of squares, so we can continue to factor. So now I know that my two zeros are at negative 1 and at 1. Therefore, my vertex is in the middle at 0. If I plug 0 in, I get 2 times 0 squared minus 2 equals 0. It's not really equals 0, it's equals y when you're solving. So when I plug 0 in, I get negative 2 for my y. So these points are negative 1 giving 0, 1 giving 0, and 0 giving negative 2. So my parabolic curve is going to look something like this. So a quick hint is to find the line of symmetry. You can either do that with symmetrical points, or you can use what we did yesterday, the negative b over 2a. And a couple x values near the line of symmetry. If you can find the x-intercepts, that's the first choice. Otherwise, you're just going to plug in and test. And the y-intercept is also very useful. All right, so this is going to simplify like so. This again is factorable. So x plus 3, x minus 2. So in my table, I know that negative 3 is going to give me 0 because of that. I know that 2 is going to give me 0 because of that. And if I'm thinking of this as an equation, I know that my line of symmetry is directly in between. So I can think about negative b over 2a, or I could just add the 2 up and divide by 2. Either way. So at negative 1/2 is going to be the vertex. I need to plug that in. So negative 1/2 plus 3 times negative 1/2 minus 2. That's 2.5 times negative 2.5, which is negative 6.25. So this graph is at negative 3, 0, 2, 0, and negative 1/2. This again is my line of symmetry, and negative 6.25 is right around there. So we've got our parabolic curve for this situation. Next up, let's go ahead and bring this over. So we have 2x squared minus 12x plus 18 equals 0. I see there's a 2 in all of that, so take the 2 out. And this again is perfect squares, so it's x minus 3 times x minus 3. Now I know that 3 gives me 0, and only 3 gives me 0. So 3 giving me 0 are my two x-intercepts as well as my line of symmetry, because the number between 3 and 3 is 3. So I need to plug in a couple other points. 0 is a super easy number to plug in, and 0 would match up with 6 because they're the same distance apart from the line of symmetry here. And if you plug 0 in, you get 18. 1's another easy number to plug in. 1 is going to match up with 5. So if you plug 1 in, you get 2 times 1 minus 3 squared, and this is equaling y because we're solving for what it equals. And so 2 times negative 2 times negative 2, and if you multiply all that out, you get 8. So I can plot 1 giving me 8. I'm going to have to count by 2s to try to fit that 18 in. And 5 is going to give me 8. And we'll see if we can squeeze the 18 in. 0 giving me 18. And 6 giving 18. So the parabolic curve looks like that. All right, last but not least. Okay, so the first step here is to bring the 3 over. Every time you have an x squared term, you want everything on one side, setting it equal to 0 so that you can hopefully factor. So the next question is this factorable? So remember, you multiply the first times the last. So 6x squared, two things that multiply to give you 6x squared that add to give you 4x. Well, the only factors of 6 are 1 and 6, 2 and 3. So this is not factorable. So now we're going to have to move into the negative b over 2a to get the line of symmetry. So a is 2, b is 4, and c is 3. Negative b would be negative 4 over 2 times a, which is 2, so that's 4, So the line of symmetry is -1. Now you plug -1 in to see what that actually gives you. So 2 times -1 squared plus 4 times -1 plus 3. So 2 minus 4 plus 3. So that gives you 1. So our vertex is at -1, 1. So we can go ahead and plot that. So what this means is that if you plug a point in on either side, you should get the exact same answer. So 0 and -2 should give you the same answer. 0 is really easy to plug in. It would just give us this number right here. So 0 would give us 3. If we're right, then when -2 is plugged in, we will get 3. So let's check that. So 2 times -2 squared plus 4 times -2 minus 3. So -2 times -2 is positive 4 times 2 is 8. 4 times, first of all, that's a plus 3. So 4 times -2 is -8, and then plus 3, because remember we added it to bring it to this side. Okay, well this is great. So -2 also gives us 3. 0 gives us 3. -2 gives us 3. And it makes complete sense that this never crosses the x-axis because it's not factorable. It might cross at a decimal, but it has no x-intercepts at all. So that's the graph of this. In the last problem for today, we can do this one of two ways. We'll do it by hand, and then I'll show you on the calculator also. So a dolphin jumps out of the water, and this models the dolphin's height above the water after t seconds. So this is the height, and this is the time in seconds. So how long is the dolphin out of the water? Now, if we find the peak, then we will know how much farther until it gets to 0, because it's the same exact distance. And since there's no c value here, we already know 0 gives us 0. So the peak would be the line of symmetry, which is -b over 2a. That's -20 over 2 times -16. A is the -16, B is the 20. So that's -20 over -32. So that would be 0.625. Now we need to plug that in to get the actual value. Well, I mean, I guess, yeah. Let's go ahead and plug it in for the heck of it. So -16 times 0.625 squared plus 20 times 0.625. So this is -6.25 plus, just using a calculator, 12.5, so that's going to give us 6.25 as the y value. So that's the maximum height of the dolphin. And then how long is it out of the water? Well, 0.625 double the distance is 1.25. So at 1.25, it should also be 0. And we can go ahead and test that. So 1.25 squared times -16 is -25. And 20 times 1.25 is +25. So yes, indeed, it does give us 0. So this dolphin is out of the water for 1.25 seconds. If you use a graphing calculator, I guess I can just explain. You just put this into the calculator, and then you're going to hit table, and I'll just do it. So So when you get your calculators, you should always do second plus 712 to clear everything. Alright, under y equals, we're going to type in the equation we were given, negative, make sure you're using the negative key, not the minus key, 16x squared plus 20x. Alright, so when I go to table, you'll see that the whole jump is already over just after 1. So we have to look at something smaller. So if you go to second window, which is table set, you can start at 0 and maybe count by 0.1. That's a good place to start. And now you'll see that we don't have symmetry yet, but it's getting close. Now, because I know that the peak is at 0.625, I could go back and I could count by 0.625. So the line of symmetry can definitely help with that. And I accidentally started at 0.5, so I have to go back and start at 0. And then you'll see the 0, the peak, and the other 0. Now let's say you want a couple more points. Well, if you count by something smaller, it just has to be a multiple of 0.625. So maybe half of 0.625, which is 0.3125. So if we count by 0.3125, it's going to be really hard to find symmetry on your own unless you can locate the line of symmetry with the negative b over 2a. This is the graph right here. You can see the dolphins coming up. The dolphins jump is ended at 1.25 seconds. So probably a good window for the graph. If you look at the x, everything's over by 2 seconds. So you could just go from 0 to 2, counting by 0.1. And then in the y, the dolphin peaks at 6.25. So you could go from 0 to 7, counting by 0.5. And then if you look at a graph of that, that will be the dolphin's jump. And you can hit trace and get your ordered pairs that way. All right. We are good for the night. Have a good evening.